Channel configurations. Think of channel configurations as the number of lanes on the digital highway connecting your memory to your CPU. In your cybersecurity journey and your work at BCC, you will often hear that more RAM is always better. While that is true for capacity, the configuration of that RAM is what determines your actual speed. You can have the most expensive, high-capacity DDR5 sticks in the world, but if you configure them in single-channel mode, you are essentially forcing a Ferrari to drive through a one-lane construction zone. To master this for the CompTIA A+ exam and your own home lab builds, you must understand the difference between single, dual, and quad-channel architectures, and more importantly, how to physically install them so you don't leave half your performance on the table. 1. Single-channel architecture. In a single-channel setup, there is only one 64-bit data path between the CPU and the memory. If you have a motherboard with 4 slots but you only plug in one single stick of RAM, you are in single-channel mode, even if that stick is very fast. The CPU can only talk to the memory using one 64-bit wide pipe. This creates a bottleneck, especially when you are running memory-intensive tasks like compiling code, rendering video, or running local AI models. 2. Dual-channel architecture. Dual-channel is the standard for modern desktop computing and high-end laptops, by using 2 identical sticks of RAM together. The motherboard doubles the data path from 64 bits to 128 bits. The CPU can now send and receive data from both sticks of RAM simultaneously. It's like opening a second lane on the highway. This doesn't double your RAM's clock speed, but it effectively doubles the bandwidth, the amount of data that can move every second. For your Ubuntu Home Lab, this can result in a massive performance boost when multitasking or handling large datasets. 3. Quad-channel and beyond. Quad-channel architecture is the domain of high-end workstations and enterprise-grade servers. This configuration creates a massive 256-bit data path. This requires a specialized motherboard and a CPU with a high-end memory controller, like an Intel Xeon or an AMD Threadripper. These systems usually have 8 or more RAM slots. In a quad-channel setup, the CPU is talking to 4 sticks of RAM at the exact same time. This is mandatory for the high-stakes cybersecurity work you're aiming for, where you might be running dozens of virtual machines simultaneously. The technician's rules for installation. As an IT professional, the most important part of this topic isn't the theory, it's the physical installation. To enable multi-channel modes, you must follow 3 strict rules. The matching rule: for the best stability and performance, you should always use RAM sticks that are identical in capacity, speed, and even the manufacturer. If you mix a slow stick with a fast stick, the motherboard will force both of them to run at the slowest possible speed. The color-coded slots. Motherboard manufacturers make your life easy by color-coding the RAM slots. On your MSI motherboard, you will likely see 4 slots, 2 black and 2 gray. To enable dual-channel mode, you must place your matching sticks in the same colored slots. Usually, this means skipping a slot, putting sticks in slots 2 and 4. For example, if you place them right next to each other in mismatched colors, you will stay in single-channel mode. The documentation check. Every motherboard is different. Before you pop those sticks in, always check the manual or the manufacturer's website. Some boards prefer slots 1 and 3, while others insist on 2 and 4 to achieve the best stability at high speeds. The Ubuntu verification. Once you have physically installed your RAM, you should always verify the configuration in your operating system. In your Ubuntu terminal, you can run the command sudo daemodecode type 17. This will spit out a detailed list of every RAM slot, showing you the speed, the size, and whether the system is successfully running in multi-channel mode.